Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts.
Hey, Herman and Corin. So, for any of our listeners interested in home computer repairs, electronics, getting into that kind of thing, we've done some really niche stuff in our episodes, but it amazes me how, and the reason that I keep sending in these prompts to build up our experimentary web of knowledge is that even though we have covered some fairly to very specific topics, such as the beloved 3M VHB tape, what a great tape, and we learned a lot, I think, in that episode about adhesive tape and making the most use of adhesives. It sounds like such a weird and obscure and frankly boring topic, but I've actually been following diligently what Mr. Poppleberry prescribed in the holding and the pressing process, and it actually works. You find stuff will actually stick to the wall and you'll get very solid bonds, and VHB can hold up remarkable weights. It is a bit like a magic tape. I'd like to continue with our journey through the rich world of adhesives, Herman and Corin. VHB is terrific adhesive tape for fixing, but sometimes there is a role in life for super glue. And I'd love to chat today about those kind of adhesives, in other words, liquid adhesives. I just went out to the local hardware store, and what I love about hardware stores, one of the few bricks and mortar businesses that I don't believe that online commerce will ever fully replace, and that's a good thing, is they kind of have that feel of a consultation / sales area. Like, you go there for the part, but you also go there for the advice. So I was telling the guy about my what I'm trying to do with a specific and very boring project regarding the Visa mounts, and I asked him for a good glue, and I ended up with, I'm quoting, R21 ironclad glue, type MP2. It's from Axia, Korean company, judging by the URL. So you've got these kind of, when you go to a hardware store or just maybe a consumer store, and you buy these super glues and you get them all over your fingers usually. It takes a while to come off and they are not that good, and then you kind of crack them open and forget to put the lid back on, and they're dried up in 2 days. That would probably describe my history in life to date with super glue. And a few days ago, in the spirit of asking every question, I said to ChatGPT, there must be a better way. So we got into this different world of adhesives, because these are very speciality. The world of glue is its own fiefdom, and you have very specific ones for different surfaces. And there's also epoxy, which I have to admit that I have almost no experience in using. But what I love to chat about, Herman and Corin, is besides the different types of adhesive your average dedicated computer hardware person might want to have and know about, the application gear, because I mentioned that getting it all over your fingers or just putting it on a scrap of plastic, something I've learned from all this work with computers and servers over the past couple of weeks, is that as much as it's not about the tools, having a few decent tools and having a decent workspace makes life so much more easy and enjoyable and gives you confidence. I say this as I beam proudly my ridiculous headlight over the living room. The head torch, that is the number one thing I recommend that people get is a good lighting to see into these very small surfaces. So I think it would be great to know. I've heard about fine tipped needles for glue application, specialized syringes, anything to take the place of a scrap of tin foil or aluminium foil for putting it on. And basically, if you are doing precision work that requires occasionally epoxy or super glue, what are some tools you might have that'll make the process better? And finally, Herman and Corin, the drying out problem. Commonly these things, just you pop them open and the next time you need them, they're already dry. So, is there any glue you'd recommend to have in the arsenal that's a bit less wasteful than what we might get today? Herman and Corin, let's delve into the world of glue and super glues in today's episode of My Weird Prompts.
Hey everyone, welcome back to My Weird Prompts. I am Corn, and I'm sitting here in our Jerusalem living room with my brother, looking out at the olive trees and feeling particularly ready to get into some technical weeds today.
Herman Poppleberry here. It is good to be back at the microphones. There is something about the dry air here that makes you really appreciate the science of things staying together, or in some cases falling apart.
So, we are continuing our deep dive into the sticky world of adhesives today. A few episodes ago, we talked about tapes, specifically the 3M brand VHB tape, which is honestly a bit of a miracle product. We talked about how it uses viscoelasticity to create bonds that actually get stronger over time. But as versatile as tape is, it has its limits. You cannot exactly use tape to fix a microscopic crack in a circuit board, or to secure a heatsink to a tiny voltage regulator in a cramped server chassis. Today, we are moving into the liquid realm. Daniel sent us a great prompt about moving from tapes to things like superglue and epoxy, specifically for people working with computer hardware and electronics.
I love this transition. Tapes are fantastic for surface mounting, cable management, and quick fixes where you have a lot of surface area. But when you are talking about structural integrity, high vibration environments, or heat dissipation in a tight space like a laptop, a tablet, or a dense server rack, you really have to understand the chemistry of liquid adhesives. It is a completely different ballgame with its own set of rules, risks, and rewards.
It really is. And Daniel specifically asked about specialty adhesives, tools for precision application like syringes and needles, and how to avoid that classic problem where you buy a bottle of glue, use it once, and 3 weeks later it is a solid rock in the back of your drawer.
The superglue tragedy, as I call it, it is a universal human experience. You go to fix one tiny plastic clip on your motherboard or a cracked laptop hinge, and you end up with a permanently sealed bottle and 3 fingers stuck together. It is frustrating, wasteful, and honestly, a bit of a rite of passage for any hardware geek. But it does not have to be that way if you know the right products and the right storage techniques.
Exactly. So let us start with the basics. When someone says superglue, they are usually talking about cyanoacrylate, or Ca goo. It is the stuff that bonds skin instantly and smells like a chemistry lab explosion. But for electronics, is standard off-the-shelf superglue even the right choice? I have heard it can actually damage components or cause weird side effects.
That is a very incisive point, Corn. Standard hardware store cyanoacrylate has a major downside in the world of electronics called blooming or frosting. You know that white powdery residue that sometimes appears around the area you glued? It looks like a tiny snowstorm hit the repair site.
Yeah, I have seen that. I always thought it was just the glue drying too fast. It is ugly, but is it actually dangerous to the hardware?
In electronics, it can be devastating. That white powder is actually the adhesive outgassing as it cures. The cyanoacrylate molecules literally take flight and then polymerize on nearby surfaces. Those vapors can settle on optical components, like camera lenses, infrared sensors, or laser assemblies, and permanently cloud them. More importantly for computer builders, it can settle on gold-plated contacts or delicate circuit traces. Because that residue is a polymer, it can act as an insulator where you want conductivity, or it can trap moisture against the board and cause corrosion over time. So, if you are working on computer hardware, you want to look for what they call low-odor, low-blooming cyanoacrylates.
Okay, so low blooming is the keyword there. Are there specific brands or numbers people should look for?
Absolutely. Loctite makes a few, like Loctite 403 or Loctite 460. These are specifically formulated to have a lower vapor pressure, so they do not outgas nearly as much. They take a little longer to set than the instant stuff, but the result is much cleaner. Another thing to consider with Ca glue is the viscosity. You can get it in everything from a water-thin liquid that wicks into cracks via capillary action to a thick gel that stays exactly where you put it. For most hardware repairs, like a broken plastic standoff, a medium viscosity is usually the sweet spot.
What about the physical properties? Superglue is usually very brittle once it cures. If I am gluing a plastic standoff back into a laptop chassis, is it actually going to hold up to the stress of a screw being turned into it?
Probably not for long. Cyanoacrylate has incredible tensile strength, meaning it is very hard to pull two pieces straight apart, but its shear strength and impact resistance are quite low. It is brittle. If you drop the laptop or even just tighten that screw a bit too much, the bond will likely shatter like glass. This is where we move into the world of epoxies, which are the heavy lifters of the adhesive world.
Right, the two-part stuff. I always feel like a bit of a mad scientist when I am mixing those on a little piece of scrap cardboard. You have the resin and the hardener, and you have to get the ratio just right.
You basically are a chemist in that moment. Epoxies are superior for hardware because they are gap-filling. Superglue needs two perfectly flat surfaces to meet with almost zero gap between them. If there is a gap, the superglue just sits there and stays liquid forever because it needs moisture and a lack of oxygen to cure. Epoxy, on the other hand, cures through an exothermic chemical reaction between the two parts. It does not care if there is a gap. It can fill a hole, recreate a missing piece of plastic, or bridge a gap between a component and a frame. Once it cures, it is much more flexible and impact resistant than superglue.
But epoxy is famously messy. If I am trying to fix a tiny trace on a board or a small plastic clip inside a phone, how do I apply it without getting it everywhere? Daniel mentioned syringes and needles. Is that how the pros do it?
It absolutely is. If you are still using the little wooden toothpick method, or heaven forbid, trying to pour it straight from the tube, you are living in the dark ages. What you want is a Luer-lock syringe system.
Luer-lock? That sounds like something I would see in a hospital or a dentist's office.
It is exactly that. It is a standardized system where the needle or the dispensing tip twists and locks onto the syringe so it cannot pop off under pressure. For electronics, you do not use sharp medical needles though. You use blunt tip dispensing needles. They are made of stainless steel and come in different gauges, which are basically different diameters.
So, like a 22 gauge needle for thin stuff, and maybe a 14 gauge for thick epoxy?
Exactly. The higher the gauge number, the smaller the opening. A 25 gauge needle is incredibly fine, perfect for placing a microscopic dot of low viscosity Ca glue on a jumper wire. A 14 or 16 gauge is much wider, which you need for thick epoxies or thermal pastes. The beauty of this is the control. You can use the plunger to dispense exactly 1/10 of a microliter of adhesive right on the tip of a pin. It makes the process so much cleaner. If you are doing a lot of work, you can even get transfer needles that allow you to pull the adhesive out of the original bottle and into the syringe without exposing the main supply to too much air.
That sounds like it would solve a lot of the mess, but what about the waste? If I mix up a batch of two-part epoxy in a syringe, that syringe and the needle are toast once it cures, right?
For two-part epoxies, yes, the syringe and the mixing tip are usually one-time use items, but you have to look at the economics of it. Compared to the cost of a ruined $300 motherboard or a $1,000 laptop, a 50-cent syringe and a 10-cent needle are a bargain. However, there is a middle ground that I think is the real pro tip for computer hardware enthusiasts: UV-curable adhesives.
Oh, I have seen these in those late-night commercials. You apply the liquid, and it stays liquid forever until you hit it with a specific wavelength of ultraviolet light, and then it hardens in like 5 seconds?
Precisely. For electronics repair, UV resins are a total game changer. Think about the stress of using 5-minute epoxy. You mix it, and the clock starts ticking. You have maybe 3 minutes to get it perfectly placed before it starts getting gummy and unworkable. With UV resin, you have infinite working time. You can take all the time you need to get the part perfectly aligned under a microscope. You can wipe away any excess with a lint-free swab without rushing. Then, once you are happy, you click your UV flashlight and boom, it is set.
That sounds much less stressful. Are there specific types of UV glue for electronics? I imagine the stuff they use for craft jewelry might not be the best for a high-end PC.
You are right to be skeptical. You want to look for electronic-grade UV resins. Some of the cheap ones you find in craft stores can be slightly conductive or even corrosive as they age. Brands like MG Chemicals make specific UV-curable coatings and adhesives. Microsoldering professionals use them to mask boards after a repair or to provide structural support to tiny jumper wires that are thinner than a human hair. There is a brand called Bondic that is popular for general repairs, but for board level work, I prefer the professional stuff like MG Chemicals 422B. It provides a tough, protective layer that also acts as an insulator.
Okay, let us pivot to a very specific type of hardware adhesive that I think a lot of our listeners might need: thermal adhesives. If you are mounting a small heatsink to a voltage regulator or a video memory chip on a graphics card, you cannot just use superglue or regular epoxy, right?
Definitely not. That is a recipe for a very expensive paperweight. Regular glue is actually an insulator. It will trap the heat inside the chip and cause it to throttle or burn out completely. You need a thermal adhesive. This is essentially an epoxy that has been loaded with thermally conductive particles like ceramic, aluminum oxide, or even silver.
I remember using Arctic alumina back in the day for some custom cooling mods on my old Pentium 4 system. Is that still the go-to?
Arctic alumina and Arctic silver are still the big names and they are very reliable, but you have to be extremely careful with the terminology. There is thermal paste which never dries and requires a physical clip or screw to hold the heat sink down. Then there is thermal adhesive, which is a permanent two-part epoxy. If you use the permanent adhesive on a graphics card processor, you are never getting that heat sink off again without a chisel and a lot of prayers.
That is a scary thought. Permanent really means permanent in that world.
It really does. There is a trick, though, that some old school overclockers use. They mix a tiny bit of regular thermal paste with the thermal adhesive. It dilutes the bond strength. It creates a connection that is strong enough to hold a small heat sink in place against gravity, but weak enough that you can twist it off with some pliers if you ever need to upgrade or repair the component. But that is definitely advanced user territory. You have to be careful not to mess up the thermal conductivity too much.
What about the modern alternatives? I've been hearing a lot about phase change materials lately.
Yes, if you want to be on the cutting edge in 26, look at things like Honeywell PTM 7950. It is technically a phase change material. It is solid at room temperature, but as the chip heats up, it turns into a semi-liquid that fills all the microscopic gaps. It is not an adhesive in the sense that it will hold a heatsink on by itself, but for performance, it is beating almost everything else on the market. If you need it to stick though, stick with the Arctic Silver thermal epoxy.
Let us talk about Daniel's last point, the drying out problem. This is the bane of my existence. I buy a bottle of high-quality CA glue. I use 2 drops to fix a mouse button. I put the cap on tight, and 6 months later the whole bottle is a solid amber mass. How do we stop the waste?
The first step is the bottle design itself. Most of the cheap superglue you buy at the grocery store has a terrible cap. It clogs, you cut the tip, then it clogs again, and eventually air and moisture get in. If you want a glue that lasts, look for brands that use a pin-in cap design.
A pin in the cap? How does that work?
There is a tiny metal pin built into the inside of the cap that slides down into the nozzle every time you close it. This physically clears any glue out of the tip and creates an airtight seal. Brands like Bob Smith Industries or the high-end Gorilla Glue bottles have this. I have had bottles of Bob Smith CA glue last for 2 years in my desk drawer and still be perfectly liquid. It is a small detail that makes a massive difference in longevity.
2 years? That is unheard of. I usually get 2 weeks before I am throwing the bottle across the room in frustration. Is there a storage trick too? I have heard people say you should keep your glue in the fridge.
It sounds like an old wives' tale, but it is actually based on real chemistry. Cyanoacrylate cures through a reaction with moisture in the air. Cold air holds significantly less moisture than warm air, and the cold temperature slows down the chemical reaction of polymerization. If you keep your unopened or tightly sealed bottles in the refrigerator, they will last significantly longer. However, there is a huge caveat. You must let the bottle come up to room temperature before you open it. If you open a cold bottle in a warm room, moisture from the air will instantly condense inside the bottle, and you will ruin the entire batch in seconds.
Oh, that makes total sense. It is like taking a camera from the cold outside into a warm house. Everything fogs up instantly.
Exactly. Now, for the less wasteful part, I also recommend buying smaller containers. Instead of one big 2-ounce bottle that you will never finish, buy a pack of those tiny single-use tubes. Even if the tiny tube dries out after one use, you have only wasted half a gram instead of a whole bottle. For epoxies, you can buy dual syringes that automatically mix the two parts in the nozzle, but those nozzles are actually quite wasteful because they leave a lot of mixed glue inside the plastic tip. I prefer the separate bottles where you can dispense exactly what you need onto a mixing surface.
What about those B7000 or T7000 glues I see in all the smartphone repair videos? They come in those big tubes with a needle nose already built. Are those good for general hardware?
Those are fantastic for specific tasks. They are basically a high-strength industrial rubber cement. The needle nose built into the tube is great for precision. The best part about them for electronics is that they are reworkable. If you use heat, like a hairdryer or a heat gun, the glue softens up and you can pull the parts apart without breaking them. That is why they are used for phone screens and laptop bezels. If you use super glue on a phone screen, you are never getting it off without breaking the glass. B7000 stays slightly flexible, which helps with vibration and thermal expansion.
So if I'm building a custom PC or fixing a laptop, I should probably have a kit of these. A low-blooming superglue for quick plastic fixes, a 2-part epoxy for structural stuff, some UV resin for board work, and maybe some T7000 for anything I might want to take apart later.
That is the perfect starter kit. And do not forget the blunt-tip syringes. They turn a messy, frustrating job into something that feels like precision engineering. It really changes your confidence level when you know you are not going to get a glob of glue on your RAM slots or inside a USB port.
I think the confidence part is key. When you have the right tool, you're more likely to actually fix things instead of just throwing them away. I remember when I tried to glue a hinge back onto my old laptop with just a tube of generic superglue. It was a disaster. It did not hold, it looked terrible, and I ended up getting glue in the keyboard. I ended up e-wasting the whole thing because I thought it was unfixable.
We have all been there. The brotherly advice here is, respect the chemistry. Adhesives are not just sticky stuff. They are complex polymers designed for specific environments and materials. If you treat them with the same precision you treat your CPU clock speeds or your cable management, your repairs will last a lot longer and look a lot more professional.
I love that. Respect the chemistry. It sounds like something a professor would say right before an explosion, or in our case, right before a very successful repair.
Hopefully, the latter. One more thing to mention is thread lockers. People often forget that thread locker is an adhesive. If you are working on a drone or a high vibration server rack, you want a tiny drop of Loctite 242, the blue stuff, on your screws. It prevents them from backing out over time but still allows you to remove them with hand tools. Just stay away from the red Loctite 271 unless you want that screw to be a permanent part of the universe.
Red means stop, blue means go, or at least go eventually. Well, I think we have covered the spectrum from the tiny needles to the big tubes of rubber cement. It is a lot more complex than just glue it and forget it.
It really is. And for our listeners, if you have a specific sticky situation you are dealing with, maybe a weird material you are trying to bond or a heat issue you cannot solve, let us know. The world of industrial adhesives is vast, and we have only scratched the surface today. There are structural acrylics, polyurethanes, and even conductive epoxies that can replace solder in some situations.
Definitely. And hey, if you're finding these deep dives into the nitty-gritty of hardware and chemistry useful, we would really appreciate it if you could leave us a review on Spotify or Apple Podcasts. It genuinely helps the show grow and helps other people find us in the vast ocean of podcasts.
It really does. We see every review, and it keeps us motivated to keep digging into these weird prompts. We have been doing this for a long time, and the community feedback is what makes it worth it.
You can find us at myweirdprompts.com for the full archive of our 774 episodes. We have a contact form there if you want to send us a message, or you can email us directly at show@myweirdprompts.com. We are on all the major podcast platforms, so make sure to subscribe so you do not miss the next one.
Thanks for listening to My Weird Prompts. I am Herman Poppleberry.
And I am Corn. We will see you next time. Goodbye.
Good.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.